Hello and welcome back. This is an update video for my MegaWang 2000 Turbo Edition hardware for the SDK version 1.0.0.9, which has just been released. You can download it from that itch page, and then when you unzip the zip file, you get this directory structure. Reading the README file, it says that the actual build and run documentation is inside C64, video hardware, and then the README file in here. There's a one-time Python setup that needs to be executed, which just gets all of the Python libraries that are used in this project. Let's switch to a command line prompt and do that first. On my machine, I've already got the libraries, so it's not going to download them again, but on your machine, it may get the libraries if you don't have them already. But they're quite common libraries. Once that's done, you need to convert the assets, and we're just going to be converting demo 14 assets today because demo 14 is the Afterburner game demo. So there's rather a lot of assets, as you would kind of expect for a mostly complete game. These assets were mostly extracted from a version of MAME that the multi-arcade machine emulator, or I think that's what it stands for, version of the source code that I updated to allow me to extract sprite graphics and also tile graphics from the arcade machine. All of the assets are in that assets directory. The assembly code, all of the source code, is in the ASM folder. Once the conversion is complete, and it takes a while because it needs to bake all of the assets, convert them, make sure all the files are optimized and everything else, then we can build the source code, which is build 14.14.bat. This is actually a lot quicker. There are several source files. There's a boot, title screen, game, mission complete source files, which get multi-loaded from the external RAM. And once it starts running, then the emulator will show a screen hopefully looking a lot like this. This is, of course, the title screen attract mode, which has the spinning ball grid, which gets exploded and then comes back again. After that is a self-playing demo with the gloved hand on the yoke, right, on the joystick, which is used for controlling the airplane. And then after that, we should see, there we go, a nice scrolling high score table. After that, we go back to the rotating ball grid, and then we can start a game. So this version of the hardware uses my 4-channel sampled audio hardware, plus 2 channels of compressed audio, the music. It also contains 2 sprite boards, scaled sprites boards, that is, and a characters layer, a tiles layer, a mode 7 layer in the background, which produces the rotated horizon and clouds, and also a combiner layer, which combines the tiles and the mode 7 layer together and helps to merge all of the layers together in the video output display. So all of the source code for this game is there. So this game is pretty much complete now. I've pretty much at the moment filled up the Commodore 64's main memory, and that's the limiting factor. So there's quite a lot of, for speed purposes, there's quite a lot of say for example divide tables, perspective and rotation calculation as well. All of the draw routines for the scaled sprites, which use rotated frames, pre-calculated, are also located in RAM as well for speed purposes. And so, yeah, I've basically got a couple of 100 bytes free in the game portion of this demo. The title screen has a lot more bytes free, but that's because the title screen only runs a cut down version of the game. This game is a single load, basically. It contains all of the takeoff and landing sequence and the refueling sequence. So the landing sequence here, the runway is actually using the tiles layer, and the tiles layer has some pre-computed scaled road or runway scan lines, which are then selected by the APU, which is the Advanced Processing Unit, which is like a copper list processing, or processor rather, but it executes a much simpler optimized opcode list, which is synchronized with the video display basically. Of course, there's the Canyon sequence as well. So this Afterburner game demo, I wanted to get all of the features that were in the arcade version of Afterburner. So we've got this canyon, the takeoff and landing sequences, the refueling sequences with the large plane that comes along. And we should also, there's also a mission complete sequence as well, but mission complete happens at stage 26. I don't think I'll be flying all the way through to stage 26 because I think I'm going to die. I don't have invulnerability switched on. I think I'll switch on invulnerability in the next playthrough of this, when I go through some of the source code options that you can use to customize this build as well. So you can see when you go and advance through each stage, you get a hit bonus for how many enemies you have destroyed during that stage. You get some nice extra points. Oh yes, then there's also this nice section here where we have a nice river flowing underneath the player as well in the map landscape. So yeah, all of these features I observed were in the arcade version, so I tried to emulate the features. So the arcade has a much higher fill rate than my version of the hardware, of course, because the arcade uses much more optimized and dedicated hardware. I'm using 74LS TTL based discrete logic ICs. So my Sprites 4 board runs at 12.096 MHz. It can run at 12.5 MHz, just about. But I think the arcade was running at least twice as quickly. This is instead of using an FPGA. But here we are. Here's the high score table. So when you enter your name, then your name just appears in the high score table after that as well. And then it goes back to the attract sequence. Let's go to the source code and turn on one of the options. Well, there's options for invulnerability. I'll show you. So let's go. It's main14.a and main14 options.a. There we go. Because it's demo 14. So it's main14 options. So we have options for invulnerability. We also have options for disabling the title screen, or disabling the game intro, or just running the game landing or refueling sequence. Those are mostly debugging options to force those sections of the game to run so I can get to them quickly and to test code changes. This version of the SDK also includes a Sprites 4 debugger, so we can turn on some extra Sprites 4 debugging windows. There we go. The layer displays a debug window, and we need another one as well, which is the second Sprites 4 layer. The layer displays a debug window. If we enable those in the feature file and then run the game build again, build 14, of course. All of the other demos were created with the earlier versions of the hardware. Demo 14 uses all of the newest additions to the hardware. So now, when I start the game, it goes into the takeoff sequence from the carrier, of course. But now I have invulnerability switched on. And of course I can run the debugger as well. So this external debugger connects to the 6502, well basically the Commodore 64, which is running behind the emulation, right? Because this hardware plugs into a Commodore 64 via the US user port. So this debugger contains all of the state of the expansion hardware, the MegaWang 2000 Turbo Edition expansion hardware. So we have the APU debugging information. We have both of the Sprites 4 boards. So in my hardware demonstration video running on a real Commodore 64 with the real hardware, I have two Sprites 4 boards. Sprites 4 are basically the super scale sprites, which makes up most of the Afterburner demo, to be honest. I can use the debugger to show memory dumps. I can use the debugger to continue execution by clicking the go button. I can break the execution. I can look at the disassembly for the APU that's also running. Here, these are the opcodes for the APU instructions. The APU runs instructions which are optimized for synchronization with the video display as it's displaying the pixels on a raster, or on the raster lines, rather. You can synchronize with the raster line. You can update video and audio hardware registers very quickly without the 6502 processor needing to do anything at all. It also contains bus mastering, so the 6502 can send updates to the video hardware and not be interrupted by the APU or vice versa. Let's move the debugging window out of the way. Now you can see the two Sprites 4 boards with the debug windows there. So this is a representation of the internal sprite board RAM, which is used for display purposes. The sprites are coloured, and each different coloured sprite represents a different sprite in the draw order list. The sprites here in the debug windows are actually rendered in a different order to those rendered on the final screen. So the final screen has front to back priority, but the debug windows have back to front priority. So you can actually see where all of the sprite overdraw happens for both for the sprite boards, basically for both sprite boards. You can, of course, also debug the 6502, 6510 code, which is the CPU in the Commodore 64. So it has full source level debugging. You can see what's being rendered on the screen at particular points in the execution. You can also have a mixed mode disassembly view as well. You can step into and step out of functions. So with invulnerability switched on, the game is obviously a lot easier. Let's go back to the options and turn on game complete on stage 2 rather than stage 26. So if we now assemble all of the source code again, run the build, we will hopefully get the mission complete screen when we get to stage 2. So after takeoff from the carrier, and then after zooming ahead a little bit to where stage 2 starts, then the mission complete screen should start. So the original arcade hardware renders all of its sprites into one layer, but those hardware sprites have their internal priority and everything like that. But I had to use two Sprites 4 boards to get a roughly comparable fill rate compared to the arcade. So there we go, there's the mission complete sequence. It brings in these nice pictures. They scroll in actually because the character screen has independent scroll registers. The mission complete is actually at the bottom there is actually a large scaled sprite. You can see that being rendered in the Sprites 4 debug window on the left hand side. And there we go, that's the mission complete sequence as well. So the game demo is actually pretty complete. All of the source code is there. You can play with the source code, update it, learn from it, see how everything is coded. Thank you very much for watching this hopefully very quick Video Hardware SDK 1.0.0.9 release demonstration, and I hope to catch you around next time. Take care, have a great day, evening or night, wherever you are.